Hello everyone, welcome back. In this video, we're going to return back to the tangent line problem, which was finding the equation of a tangent line to a curve at a particular point. Now, if you recall, we approximated the slope of the tangent line by using the slopes of secant lines. And as we use points which are closer and closer to P, then the slopes of the secant lines will get closer and closer to the slope of the tangent line. And now we can determine the exact slope of the tangent line by using limits. So the tangent line to the curve y equals f of x at the point P, which has coordinates a, f of a, is the line through P with the slope given by the limit of f of x minus f of a divided by x minus a as x approaches a. So let's have a look at where this formula comes from. So suppose that we want to determine the slope of the tangent line to the curve y equals f of x at the point P, which has coordinates a, f of a. Now, if we let Q be another point on the curve, we'll let the coordinates be x, f of x. Then if we calculate the slope of the line that passes through these 2 points, we end up with this formula. So if we calculate the rise over the run, we get f of x minus f of a over x minus a. So this is the slope of the secant line that goes through the points P and Q. So now if we want to find the slope of the tangent line, what we want to do is let the point Q get closer and closer to P. In other words, we want to take the limit of x and let it approach the value of a. And if we let x approach a, then the slope of the secant line will become the slope of the tangent line. So the slope of the tangent line is the limit of the slope of the secant line, where we let x approach the value of a. Now there is another expression for the slope of the tangent line that is somewhat easier to calculate. So let's also have a look at another formulation for the slope of this tangent line. So if we let the variable h be x minus a, then if you rearrange this equation, we can also have that x would be equal to a plus h. And if we substitute these into the slope of the secant line through P and Q, we end up with this formula. We get f of a plus h minus f of a, all divided by h. So the x gets replaced with an a plus h, and the x minus a in the denominator gets replaced by an h. Now notice that if we let x approach a, then h will approach a value of 0. And so we can calculate the slope of the tangent line by taking the limit of f of a plus h minus f of a all over h, where h goes to 0. So here is another illustration of what's happening. So our 2 points are P and Q, which has coordinates a, f of a, and a plus h, f of a plus h. And again, if we calculate the slope of the secant line through these 2 points, we end up with this formula. And if we let h approach 0, then the point Q will get closer to P. So as h goes to 0, a plus h will go towards a. So we can determine the slope of the tangent line by using this formula as well. Now, because this type of expression appears quite often in the sciences, we actually give it a special name. We call this the derivative of a function f at a number a, and it gets its own notation which is f prime of a. So f prime of a is given by this limit. So the tangent to the curve y equals f of x at the point a comma f of a is the line through a comma f of a whose slope is equal to f prime of a, which is called the derivative of f at a. So now let's use this limit in order for us to calculate the slope of the tangent lines, and then we can use it to find the equations of tangent lines. So let's have a look at some examples of finding the equation of the tangent line at the given point. So we have y equals 4x minus 3x squared, and the point is 2 comma negative 4. So we want the equation of the tangent line that passes through this point, and so our a and f of a is given as 2 comma negative 4. So our a is 2, and if you calculate f of 2, where our function is 4x minus 3x squared, we end up with negative 4. So there are two things that we need in order for us to calculate the equation of the tangent line. So we need the slope of the tangent line as well as any point that lies on the line. We already given that 2 comma negative 4 is the point on the line, and so all that's left is to calculate the slope of the tangent line. So to find the slope of the tangent line, we want to find the derivative of f at the number 2, since our a value is 2. So the derivative of 2 is given as the limit as h goes to 0 of f of 2 plus h minus f of 2 all divided by h. So in order to calculate this limit, we need to determine f of 2 plus h and f of 2. So let's calculate these values first. So f of 2 plus h is 4 times 2 plus h minus 3 times 2 plus h squared. So if we distribute through the brackets, we get 8 plus 4h minus 3, and we need to FOIL these brackets. So we have 8 plus 4h minus 3 times 4 plus 4h plus h squared. So now we can distribute the negative 3 through the brackets, so that's negative 12 minus 12h minus 3h squared. And now collecting like terms, we get negative 3h squared minus 8h minus 4. And so now we also need to calculate f of 2, which is 4 times 2 minus 3 times 2 squared. So that is 8 minus 3 times 4. So that's 8 minus 12, which is negative 4. So now we can determine the slope of the tangent line. Which was f of 2 plus h minus f of 2, all divided by h. So we have the limit as h goes to 0. F of 2 plus h which is negative 3h squared minus 8h minus 4. And then we subtract f of 2, which is negative 4. And that's all divided by h. So now let's simplify. We have a negative 4 and a minus a negative 4, which is positive 4. So the negative 4 and the positive 4 will cancel. And so we're left with negative 3h squared minus 8h all over h. We can factor in h from the numerator, which leaves us with negative 3h minus 8 all divided by h. And now we can simplify by canceling the h. And so that leaves us with the limit, as h goes to 0, of negative 3h minus 8. And now we take the limits, so letting h goes to 0, we get negative 3 times 0 minus 8, which is negative 8. And so the slope of the tangent line is negative 8. So now we can write down the equation of the tangent line. And here I will use the point slope form of a line, which is y minus y1, which is equal to m times x minus x1. So we determined our slope to be negative 8, and we know that the tangent line goes through the point 2 comma negative 4. So we have y minus negative 4 is equal to negative 8 times x minus 2. So y plus 4 equals negative 8 times x minus 2 is the equation of the tangent line. So here is the graph of 4x minus 3x squared. And so we want to find the equation of the tangent line, which goes through 2 comma negative 4. And we found that to be y plus 4 is equal to negative 8 times x minus 2. And so here's the equation of the tangent line that passes through the point 2 comma negative 4. So let's have a look at the next example. We have y is equal to 2x plus 1 over x plus 2, and our point is 1 comma 1. So to find the equation of the tangent line, we need to find the slope and a point that's on the line. Since we know that the point is 1 comma 1, all that we need is the slope of the tangent line. And so the slope of the tangent line is the derivative of f at 1. So this is the limit, as h goes to 0, of f of 1 plus h minus f of 1, all divided by h. So we need to determine f of 1 and f of 1 plus h. So let's first calculate f of 1 plus h. This is 2 times 1 plus h plus 1 divided by 1 plus h plus 3, or plus 2. And simplifying, we can distribute the brackets. That gives us 2 plus 2h plus 1 all over h plus 3. And this is 2h plus 3 divided by h plus 3. Next, we'll look for f of 1. So this is 2 times 1 plus 1 all over 1 plus 2, which is 3 over 3, which is simplified to 1. So now we can determine the slope of the tangent line. So that's the limit as h goes to 0, f of 1 plus h minus f of 1 all over h. So we have the limit as h goes to 0 of 2h plus 3 divided by h plus 3 minus 1 all over h. So now let's simplify our limit. In the numerator, we have two fractions. So let's combine the two fractions by making a common denominator. And a common denominator is going to be h plus 3. So we need to multiply the second fraction by h plus 3 over h plus 3. So we have the limit as h goes to 0 of 2h plus 3 over h plus 3 minus, in brackets, h plus 3 over h plus 3. And that's all divided by h. And now that they have the same denominator, we can combine the fractions. So we have 2h plus 3 minus h plus 3 all over h plus 3, and that's over h. So now rather than working with two fractions, let's rewrite it so that we only have one. So we can treat the denominator as a fraction of h over 1, and now we can multiply by the reciprocal of the denominator. We will also distribute the negative through the brackets in the numerator. So we have the limit as h goes to 0 of 2h plus 3 minus h minus 3. That's all over h plus 3. And then we will multiply this by the reciprocal of the denominator, which is 1 over h. So now let's simplify the numerator. We have positive 3 and the negative 3. And 2h minus h will simplify to an h. And that's all over h plus 3 times h. We can now simplify the h's. So now we have the limit as h goes to 0 of 1 over h plus 3. And now we can take the limit. So if we let h go to 0, we get 1 over 0 plus 3, which is 1 over 3. And so the slope of the tangent line is 1/3. So now we can write the equation of the tangent line. So we have y minus 1 is equal to 1/3 times x minus 1. So this is our equation of the tangent line. So in the next exercise, let's find the derivative of f at 0 for the following functions. So here we're looking for the slope of the tangent lines where the x-coordinate is 0 on the curve. So we have f of x is 3x squared minus 4x plus 1. And we're looking for the derivative at 0. So this is the limit as h goes to 0 of f of 0 plus h minus f of 0 all divided by h. And we can simplify this further. We have the limit as h goes to 0. 0 plus h is just h, so this is f of h minus f of 0 all over h. So what we need is f of h and f of 0. So f of h is given as 3h squared minus 4h plus 1, and f of 0 is 3 times 0 squared minus 4 times 0 plus 1, which is equal to 1. So now we can determine f prime of 0. We have the limit as h goes to 0. F of h, which is 3h squared minus 4h plus 1. We subtract f of 0, which we determined to be 1, and that's all divided by h. So now we can cancel the positive and the negative 1, and we're left with the limit as h goes to 0 of 3h squared minus 4h divided by h. So we can factor in h from both terms. We have h times 3h minus 4 all over h, and now the h's can cancel, and this will give us the limit as h goes to 0 of 3h minus 4, and now we can take the limit. So if we let h go to 0, we get 3 times 0 minus 4, which is negative 4. And so f prime of 0 is negative 4. In the next example, we have f of t, which is 2t plus 1 over t plus 3. So f prime of 0 is the limit as h goes to 0 of f of h minus f of 0 all divided by h. So what we need is f of h and f of 0. F of h is 2h plus 1 divided by h plus 3, and f of 0 is 2 times 0 plus 1 divided by 0 plus 3, which is 1/3. So now f prime of 0 is the limit as h goes to 0, f of h, which is 2h plus 1 over h plus 3, minus f of 0, which is 1/3, and that's all divided by h. So now let's simplify our limit. In the numerator, we have two fractions. So let's make a common denominator, which is 3 times h plus 3. So we need to multiply the first fraction by 3 over 3, and the second fraction by h plus 3 over h plus 3. and that's all divided by h. So we have the limit as h goes to 0. So now let's distribute the brackets. We have 6h plus 3 over 3 times h plus 3 minus h plus 3 divided by 3 times h plus 3. And that's all over h. So now we can make a common denominator. Or since we have a common denominator, we can now combine the fractions. So let's also distribute the negative through the brackets as we're simplifying. And we'll also rewrite our limit as a single fraction instead of two fractions. So we'll multiply by the reciprocal of the denominator. So we have 6h plus 3 minus h minus 3 divided by 3 times h plus 3, and we multiply this by the reciprocal of h over 1, which is 1 over h. So now let's simplify. We have positive 3 and negative 3. So we have the limit as h goes to 0 of 5h divided by 3 times h plus 3 times h. We can now cancel a common factor of h. And now let's look at our limit. We have the limit as h goes to 0 of 5 over 3 times h plus 3. And if we take the limit, so letting h go to 0, we get 5 over 3 times 0 plus 3, so 5 over 9. In the last example, we have f of x is the square root of 1 minus 2x. F prime of 0 is the limit as h goes to 0 of f of h minus f of 0, all divided by h. So we need to look for f of h and f of 0. F of h is the root of 1 minus 2h, and f of 0 is the root of 1 minus 2 times 0. So this will simplify to the root of 1, which is 1. So f prime of 0 is the limit as h goes to 0 of f of h, which is the root of 1 minus 2h, minus f of 1, which is 1, and that's all divided by h. So here we're dealing with the limit of root 1 minus 2h minus 1, all divided by h as h goes to 0. So to handle this type of limit, we will look at rationalizing the numerator. So we're going to multiply by the conjugate of the numerator, which is the root of 1 minus 2h plus 1. So now let's FOIL the numerator. So root 1 minus 2h times root 1 minus 2h gives us 1 minus 2h. The square roots will cancel. We get the root of 1 minus 2h times 1. And we get negative 1 times the root of 1 minus 2h. And then negative 1 times positive 1 is negative 1. And that's all over h times the square root of 1 minus 2h plus 1. So now let's simplify the numerator. The positive 1 and the negative 1 will cancel. The root 1 minus 2h and the negative root 1 minus 2h will cancel. And so the numerator will simplify to a negative 2h all over h times root 1 minus 2h plus 1. So now we can cancel the factors of h. So we're left with the limit as h goes to 0 of negative 2 over root 1 minus 2h plus 1. And if we let h go to 0, we get negative 2 divided by the root of 1 minus 2 times 0 plus 1. So negative 2 over root 1 plus 1. And the root of 1 is 1. So that's negative 2 over 2, which gives us negative 1.